All right, so before we start section 3.3, I wanted to go over some basic ideas for um, basically fractions and mixed numbers. So back in the day, you probably learned about mixed numbers. And mixed numbers were useful for explaining everyday measurements. For instance, like 1 2/3 cups of flour. You wouldn't say 5/3 cups of flour because that would be a little confusing. 2.5 feet. Okay, so everyday measurements, we use mixed numbers a lot, but we're going to go into more about what the meaning is. So I'm going to go to the 1 2/3. Let's say I have 1 2/3. What does that really mean? So what it really means is 1 plus 2/3. We get rid of in mixed numbers, we don't write the plus, but there really is a plus sign there. So there's an invisible plus sign in between the two. So that's why we kind of get confused because when we're doing higher level math, we avoid mixed numbers because it can be confused with multiplication, and you don't want that to be the case. So usually higher level math, you avoid it unless you're answering a word problem where it's an everyday measurement. But anyway, let's go over the meaning behind all of these. So let's see, 1 2/3 is 5/3. So let me go ahead and rewrite this a little bit. We have 5/3 is the same thing as 1 plus 2/3. All right. Now, each of these has names, and we're going to be using these names in this section a lot. So the top is called the end. Well, this one we don't use a lot. Usually I'll just say the numerator. Now, the fancy word that they're going to use in this section is they'll say dividend. Whereas this one on the bottom, they call it the divisor. So you'll hear me say the word divisor a lot, but usually I don't say dividend because it just confuses people. I'll just say the numerator or the top. This number here is called the quotient. Okay. The number here is called the remainder. And then again, on the bottom, you have the divisor. Okay. So in general, each part of this division has a name. Whenever you divide, every portion of the division has a name. So again, I can make something up. Let's see, I can say 8/3. Let's do one a little different. Let's say 9/4. That fits into it twice. And then there's going to be 1/4 left over. So again, this part here is the quotient. I use purple, so let me repeat purple. Okay, and the remainder is the part that's on top of the fraction. And then the divisor happens twice in the equation. So for the divisor, and usually you won't hear me mention the dividend, but anyway. Now I did this in my head, but I could have also done this using long division. If I could spell right. And so in long division, if I had 9/4, what you would do is you would put the 4 on the outside, the 9 on the inside. Let me try to make it look nice. Okay, and then you would just do some math. You would ask yourself, all right, how many times does 4 fit into 9? It fits twice. So the 2 goes on top. Then you would say 4 times 2 is 8. You would subtract, and you'd be left with a 1. Okay? Since I already know what everything is called over here, let me kind of move it closer. So everything still has a purpose. So I guess that's kind of in the way. Let me move it up here. All right. So looking at this, you can see that the divisor goes on the outside. The top or the numerator are the dividend. I'll just say numerator. Goes on the inside. The 2 is the quotient. The quotient goes on top. And then we do some math. And then on the bottom, we end up with the remainder. So for more complicated problems where you're doing long division, it's good to know where everything goes, because you do the long division first, and then from there you construct your number. So let me make up an example. Let's say I have, I'm just totally making this up. Let's say I have 234 divided by 5. Okay, so we know that we would set it up as the divisor goes on the outside, the numerator goes on the inside, and then we do the math that hopefully everyone kind of remembers from grade school. But you ask yourself, how many times can 5 fit into 234? Now, if you're doing this without a calculator, you break it down and go slower and say, how many times can it fit into 23? It fits 4 times. 5 times 4 is 20. We subtract 3 as our answer. Bring down the 4. 5 fits into 34 6 times. 6 times 5 is 30. Subtract. And we end up with the remainder of 4. And so from there, I know all my pieces. I know that 234 over 5 is equal to, you take the quotient, (46) plus, and then you take the remainder, 4 over, and then the divisor. If you wanted to write it as a mixed number, you would say 46 and 4/5. Okay, but this process is what we're going to go over today. We're going to go over long division. And it's exactly the same as what I just did with regular numbers, except instead of numbers, we're going to be dealing with x's. Okay? And again, the nerd in me wants to go over why or how this matters. So let's say you're dealing with a number. I'll use the 234. This is the ones place. So we're going to look at place value. So this is the ones place. This is the tens place. And this is the hundreds place. I'm trying to tie in why this applies to polynomials. So this is basically saying 2 times 100 plus 3 times 10 plus 4 times 1. The reason why it's a polynomial is these guys right here. So think of 1 as 10 to the 0. So I have 2 times 10 squared plus 3 times 10 to the 1 plus 4 times 10 to the 0. Okay? Now we call this base 10. It's the number system that we're used to. But when you're dealing with numbers, it can be any base. Or not in situations, but you can think of a number as being converted to any base you want. So even though we're used to base 10, what happens if we make it to where it's any base? And this is just a rough oversimplification of what's going on. But notice if I replace the 10 with an x, I end up with 2x squared plus 3x plus 4. And so that's the tie-in of why all the math for long division is the same as for polynomials as it is for regular numbers. It's because the base 10 system is just a format of polynomials where x is equal to 10. Anyway, that's me done nerding out. So let's go back to long division of polynomials. Yay. So what's different about this is there's now x's in our fraction. So we're dealing with f of x over g of x. Usually f of x has a larger degree. So this guy right here has a larger degree, whereas this one down here has the smaller degree. Okay, and just like that, if a larger number is over a smaller number, you can simplify it. Same thing here. If a larger degree polynomial is over a smaller degree polynomial, you can simplify it, and we do that using long division. Now here's all the steps for long division. Rather than read them out one by one, we're just going to go ahead and do the first problem. And you're going to see it carries all the same characteristics as if we were actually doing it with just numbers. So if I rearrange this so that it's in order, 6x cubed minus 5x, minus x squared minus 5x plus 4, and I divide that by 3x minus 2. Notice that we have a degree 3. Where can I fit that? I'll just put it up here. We have a degree 3 on top, and we have a degree 1 on the bottom. Okay? Since the top is a higher degree, I can perform long division and figure out what my quotient and my remainder are. So just like before, if I go, remember we had the divisor, we had the numerator. So it's above here too. We're basically doing, the bottom is what goes on the outside. So I have 3x minus 2. I do the long division sign, and then I write down 6x cubed minus x squared minus 5x plus 4. And just for illustrative purposes, I'm going to do that same problem I did. How many times is this going to go? Twice? Yeah. So just for illustrative purposes, I'm going to also do this problem on the side, the 234 over 5. And I want you to see the parallels between the two problems. So if I did 5 over 234. Okay, my first task if I'm doing this problem on the side is how many times does 5 fit into 23? Well, when you're dealing with polynomials, we're going to ask ourselves the same question. How many times does 3x minus 2 fit into this problem? But since we're so used to numbers, we kind of do a lot of steps mentally. What you could do to figure that out is you look at the leading term. Okay, so on the side, we're going to do 6x cubed divided by 3x. Okay, if we do that math, we end up with one of the x's cancel, 6 over 3 is 2. We get 2x squared. That's the number that goes on top. Now in my 234 divided by 5 fits into 23 4 times, and that would be a 4. So we're kind of on that same step. You write the number on top, okay? Whereas we did 23 over 5, I did the leading term divided by the leading term. So 23 divided by 5 is the same idea as 6x cubed over 3x. And then, after that, if you're doing long division, you multiply those two numbers. 5 times 4 is 20, and you write the number underneath. We're going to do the same thing. The 2x squared that we just wrote, I'm going to multiply it to the outside. So this becomes 2x squared times 3x minus 2. And I'm going to write the answer to that underneath. So this is 6x cubed minus 4x squared. I'm going to write that underneath. Okay. Now in the long division for the numbers, you would subtract after that. That would give me 3. Same idea. We're going to subtract. Now when you subtract, you have to subtract properly. It's 6 minus 6, which is 0. Negative x minus, the minus distributes. Negative x minus negative 4 is really plus 4. So negative 1 plus 4 is positive 3. Now in the long division example, you would bring down the 4. Here we're going to do this. We're going to do the same thing. We're going to bring down the minus 5x. That is one step of this whole process. Okay? Notice it's exactly the same as doing it with numbers, except that we're doing it with x's now. And to help you out, I'm kind of showing the side work that's needed in order to make this happen. I'm going really bad with my spacing today. Okay. So after we're done with that, we repeat the process. We started by, let me erase this, dividing leading terms. So this is one step. So now I'm going to do the same thing. I divide leading terms. My new leading term is 3x squared. So I'm going to be doing 3x squared over 3x. And x's cancel, so there's one x left. And the 3's cancel, so that's just x. The answer you get goes on top. Plus x. Okay. Here I'd be doing the same thing. I'd be saying 34 fits into there 6 times. The 6 would go on top. Now we multiply again, but we only multiply the number that we just put on top. You would say 6 times 5 is 30, and you would write it underneath. So same thing. Just the number that I got and what's in front, and I'm going to multiply those two. So that gives me 3x, or x, sorry, times 3x minus 2, and that's 3x squared minus 2x. I'm going to write that underneath. Again, we subtract. Be sure to subtract the whole thing, meaning that there could be double negatives. 3 minus 3 is 0. Negative 5 plus 2, because remember there's a minus on the outside, minus a negative. That gives me plus 3. Or sorry, negative 5 plus 2 is negative 3. Let me switch colors again. and then we bring down the 4. And we repeat the process one more time. Okay, so here 6 times 5 is 30. We subtract. And notice in this problem that I did, we're done. And here we're going to have to do it one more time. I figured I better give you an example that was a little tough so that you'd be ready for it. So we start by dividing the leading terms one more time. That's just 1. I put the 1 up top. I multiply the 1 that I just put times the outside. And that's just 3x minus 2. I write it underneath. Oh, sorry. And a good example with these long division problems is it's really easy to make a mistake because there's so many little steps that you do. So I apologize. Oh, look, that canceled out right. So minus 1. So this is really a minus 1. Negative 3x plus 2. Negative 3x plus 2. I can subtract. Those cancel. 4 minus 2 is 2. And there you go. So we have everything we need. Let me get the side work and move it to the side. Sorry. There we go. Oh, fun, fun, fun. So now we can write our final answer. So after you have all of this stuff done, you look it over, and I can put it up here. And our answer is going to be quotient plus remainder over divisor. Okay, just like with any mixed number. Quotient plus remainder over divisor. I did it over here too. Okay, so quotient, remainder over divisor. So it's the same thing. So my quotient is what's on top. So my answer is going to be 2x squared plus x minus 1 plus remainder. The remainder is just 2 over divisor, that's my denominator, 3x minus 2. And there you go. So that's the answer you're looking for. What they're saying is that this equation that we started with is the same thing as this one. All we did was we found how many times does 3x minus 2 fit into it. Turns out it fits this many times, 2x squared plus x minus 1, but there's a remainder of 2. Okay, now these, I mean, you have to get used to doing these. It's not something you can just look at and be like, oh yeah, I got it, and not practice and then expect to be able to do it on an exam. You have to actually do these and work them out. Okay, so you have to practice. So I want to go to Desmos real quick. Desmos. And I want to show you something. So if I write the original problem, which was 6x cubed minus 5x plus 4, and then plus 4 minus, and then we have minus x squared, and then the whole thing divided by 3x minus 2. Okay. Notice that we get a graph. It looks really nasty. I'm going to make it go between -5 and 5. Even more than that, let's say -3 and 3. So we get a graph that looks like this. Now notice it has a vertical asymptote, and that's really easy to find. The denominator can't be 0. So 3x minus 2 equals 0. That's what it can't be. So I'm going to make that a dotted line. Okay. So aside from that, though, if I zoom out, notice that the graph looks like a parabola. Well, what parabola does it look like? And it turns out that this is what the quotient is. My quotient, let me put a note. Quotient is, and I'm going to put this in parentheses because it's not really the definition of an asymptote. Okay, what I mean by asymptote is that the graph looks like it. So if I go back over here, my quotient for the problem was 2x squared plus x minus 1. So if I go back to Desmos, 2x squared plus x minus 1, notice that there it is. This is my quote-quote asymptote for the graph. So my graph looks like 2x squared plus x minus 1, except it has a vertical asymptote at 2/3. If you solve 3x minus 2 equals 0, that's 2/3. Isn't that pretty cool? Now, if I graph my 2x squared plus x minus 1, and then I add the 2 over 3x minus 2, the remainder, notice that I get the exact same graph as my original problem. Meaning, let me hide these asymptotes. So notice that, oh, can't see it, this one. Notice that it is the exact same graph. Okay? The quotient is what the graph looks like, and the denominator tells you where the vertical asymptotes are. They don't go that far in this section, but I thought it's really cool. It's cool if you know what you're doing as you're doing this, because you have more intuition if you make a mistake or if something goes wrong. Anyway, let's do this next problem. And there's Pusheen. All right, so do exactly the same thing for this one. I have 2x to the fourth plus 3x cubed minus 7x minus 10. The first issue here, and this goes with numbers. So what's the difference between 234 and 2304? Okay, we know that the place value is what matters. This 0 is really important. It holds a place value. Same thing with these. I have 2x to the 4 plus 3x cubed. Notice there's no x squared. I have to have a place value for it. Minus 7x minus 10. And this whole thing divided by x squared minus 2x. Okay? You can put plus, so if the place value is in the middle, if the missing place value is in between numbers. So here the x squared is in between x cubed and 7x. Here there's really a plus 0, but we call that a trailing 0. Since the plus 0 is all by itself on the end, it's not sandwiched between two other things, I can actually leave it off and I won't have any issue with the problem. Okay, so if your 0 sandwiched between stuff, you have to add it. And now let's go ahead and do this problem. If you want to try it on your own, feel free to pause the video, try to work it out. But let's go. So I have x squared minus 2x, and I have 2x to the fourth plus 3x squared, 3x cubed, sorry, plus 0x squared minus 7x minus 10. So, okay, if you were confused in the last problem, because I was trying to throw all the theory at the same time as I was doing it, let's just start from scratch. You look at this problem and you say, what do I do? First task, divide the leading terms. So when you divide the leading terms, you end up with 2x to the 4 over x squared. And that leaves you 2x to the 4 over x squared is 2x squared. You're going to write the number on top. Notice I wrote it in line with the x squareds. Okay, you don't have to, but it helps keep everything organized. Anyway, so I did that. Now you're going to multiply to the divisor. So I have 2x squared and my divisor is x squared minus 2x. When I do that, I get 2x to the fourth minus 4x cubed. I'm going to write that underneath. 2x to the fourth minus 4x cubed. Then I subtract. Okay, 2 minus 2 is 0. 3 minus a negative 4. That double negative is the killer of everybody. It destroys people. 3 minus negative 4 is 7x cubed. I'm going to switch colors now. Then I bring down the next term. So all of this is one step. Now that you've done it, let's go on to the next step. Okay. So the next step, again, same thing. Divide leading terms. So now my leading term is 7x cubed divided by x squared. Well, that's just 7x. I write my answer on top, a positive 7x, and then I multiply to the divisor. So 7x times x squared minus 2x. That gives me 7x cubed minus 14x squared. I write that underneath. I subtract. 7 minus 7 is 0. 0 minus negative 14 is positive 14x squared. And I bring down the next one. So I've done that one. Let me go to green. Okay. So be careful about that double negative. It's not minus 14x squared, it's positive 14x squared. So now we can go to the last step. So now again, I divide leading terms. My leading terms this time are 14x squared over x squared, which is just 14. That goes up top. I multiply it to the outside. I have 14x squared minus 2x. That gives me 14x squared minus 28x. I write that underneath. I subtract. Okay, 28 minus 7 is 21. Or sorry, negative 7 plus 28, because the double negative, that turns into a positive 21 minus 10. Okay, you stop once this has a smaller degree. Notice that this is degree 1. The top is degree 2. Once it has a smaller degree, you stop. You're done. So there we go. Now that I did all of this, my final answer is going to be quotient plus remainder over divisor. My quotient is 2x squared plus 7x plus 14, then plus remainder, 21x minus 10, over divisor, x squared minus 2x. There you go, and that's your final answer. So again, these take practice. If you have any questions or you have difficulty, I know there's a lot of tutorials on Khan Academy. If not, email me, and I'll do what I can to find you some worksheets that you can work on to just practice doing these long division problems. Again, just to humor y'all, let's go ahead and graph it. 2x to the 4th plus 3x cubed. Let me erase all this stuff. 2x to the 4th plus 3x cubed minus 7x minus 10. And then the whole thing divided by x squared minus 2x. Okay. So looking at this graph, there's my parabola. Let's get this graph, let's kind of make it a little easier to view. So notice that this looks a little weird. X squared minus 2x equals 0 has two solutions. At x equals 0, 0 minus 0 is 0, and x equals 2. So I can make these, my denominator shows my vertical asymptotes. So let me add that as a text. Okay. Now my quotient is the asymptote for the graph in general. Notice this is a big parabola. And so 2x squared plus 7x plus 14. There you go. Notice that the graph looks like that as you zoom out. The two graphs are pretty much the exact same thing. The only time it gets off from it is because of the vertical asymptotes. The graph can't touch them, so it has to avoid them. So anyway, there you go. I think that's cool. Yeah. All right, anyway, moving on. Now, long division's cool, but there are shortcuts. And that shortcut, a lot of you probably were like, why is he not doing that? Well, now we're going to do it. It's called synthetic division, right? But this only works in a certain case. The denominator has to be x minus c. So you can have your numerator, it can be anything. But your denominator has to be, like, for instance, x minus 3, or it can be x minus 4. or it can be, I'm just going to put a little wiggly line, x minus negative 2. But what is x minus negative 2? That's just x plus 2. So as long as you have something that looks like x plus or minus a number, then this synthetic division will work. It only works in that case. So let's look at this first example. If your denominator was x minus 8, remember the x minus is part of the formula here. Let me erase this. The x minus is part of the formula, and then c is the number next to the minus sign. So x minus is part of the formula, so that means that c is 8. Okay. Here we have the plus. This is like saying x minus negative 7. The x minus is part of the formula, so c is negative 7. Same thing here, x minus negative pi, so c is negative pi. X minus is already there, so c is 3/2. If you want to view it as it's the opposite of what it looks like, go for it. All right, now here I did this on purpose, 3x minus 4, nothing. This does not match the format. Whoa, zoomed in way too much. Okay, so notice that this is not okay. This problem has a number in front of there, and because of that number, it's not x minus c, so there's no value of c. You can't do it. Okay, same thing here. Notice because of that exponent, there's no value for c. You can't do it. All right. With that being said, I'm going to show you how to do synthetic division. There's a long list of steps, just like there was with the long division, but I'm not going to write down the steps because honestly, it just makes things more confusing. So I'm going to show you how it works. It's actually kind of fun. Okay. So to do synthetic division, what you do is first you find c. And then once you find c, you're going to write your problem like this. C goes here, kind of like a square bracket thing goes on top. And then you're going to put the coefficients of the numerator. Okay, the coefficients are just the numbers in front. And when you're doing this, you have to be careful for place value. So in this problem, I look at this, the x minus is part of the formula. So I know that c is equal to 3. So what I'm going to do is I'm going to do 3. I do this little bar thing. And then I'm going to put the coefficients of the numerator. So the coefficients of the numerator are just going to be 2, negative 3, negative 11, and 7. Notice that there's no x's. Just the coefficients. I put a bar underneath. All right. So if you were tuned out up until now, I please want you to tune back in so I can kind of show you how to do this. All you do is your first step is you drop down the 2. Okay. And then you multiply it to the outside. So you get your number that you just got, you multiply it to the outside. 2 times 3 is 6. You put the number underneath the next one, add them up. Negative 3 plus 6 is 3. multiply. 3 times 3 is 9. Add them up. Negative 11 plus 9 is negative 2. 3 times negative 2, negative 6. Add them up. You get 1. And then you put a box under the last number. So, after you write down the first number, okay, after you do that, then you start the process. And again, the process is just multiply to the outside. Right underneath the next number. Add. And repeat. Okay, so you bring down the first number. I brought down the 2. Multiply to the outside. Write it underneath. Add. Multiply to the outside. Right underneath. Add. Multiply to the outside. Right underneath. Add. And the cool thing is that if you've done it properly, what you end up with is numbers, and then the last number you put in a box. This last number is your remainder. Okay? These are the coefficients of the quotient. I didn't give myself enough room. Okay, so these are the coefficients of the quotient, and it's always going to be 1 degree less. So notice I started this problem as a degree 3. So that means that this has to be degree 2. So my final answer is going to be 2x squared plus 3x minus 2, and then I have a remainder of 1. And my denominator for the whole thing was x minus 3. So this process is called synthetic division. It's a lot quicker than long division, but you can only use it in special cases. So let's go ahead and do these next two, and then we'll keep chugging and see how far we can get. Going to shrink this. All right. So without all the explanation, let's see if we can do this next one. The first quick thing to notice is that there's no placeholder. Notice that I'm missing 0x squared. So I got to be sure to get that. My c is -2. Remember, it's x minus -2. And so I'm going to work it out. I have -2. The coefficients of the top are going to be 5 is the first one. Then a 0, because that's the missing placeholder. Then a 6. Then an 8. Then I do my steps. So my steps say bring down the first number, multiply, right underneath, add them up. Multiply, right underneath, add them up. Multiply, so that's 25, that's -52. And then that becomes 8 minus 52, that's 52 minus 8, -44. If I screwed that up, I don't even trust myself anymore. Okay. Gilbert doesn't trust himself. Yeah, okay. So that works out. -44. Then that's all you got to do. So now that I have that, I know my quotient is this. I started with a degree 3, so my answer has to be a degree 2. So this tells me that my answer is going to be 5x squared minus 10x plus 26. And if it's minus 44, instead of saying plus negative 44, I could just write the minus on the outside. Minus 44 over x plus 2. See, wasn't that better than long division? Yay, synthetic. We're going to actually use synthetic a lot. So it's going to be in your best interest to get it down. Okay, got one more. Here there's a lot of missing zeros. Notice that I'm missing 5, 4. I'm missing 0x cubed, and I'm missing 0x. So here c is equal to 1. I write the coefficients. So start with 2, then a negative 3, the missing 0, then a 1 because there's nothing in front of x squared, then the missing 0, and then another 1. So we work through it, bring down the 2, multiply, add them up, multiply, add them up, multiply, add them up, multiply, add them up, multiply, add them up. See, that's why we like it. So instead of having to do 4 complete steps of long division, we instead get our answer very quickly. We started with a degree 5, and so now it's going to be 1 degree less. So my answer is 2x to the 4th minus x cubed minus x squared. I don't need to write the 0, 0. I can just say plus 1 over x minus 1. Okay, so on the homework, I put a bunch of these because I really want you to practice them. They don't take too long. So the long division, I can't really put a lot of them because they take forever. But the synthetic, they go real quick. And so once you get the hang of it, hopefully things should be pretty smooth. All right, so the last bit of this section is the remainder theorem. How many pages we got anyway? Yeah, 3 pages left. All right. So here we have the remainder theorem. The remainder theorem states, if a polynomial is divided by x minus c, the remainder is f of c. So what the remainder theorem says that if you have a polynomial, where again f of x is a polynomial, if I divide it by x minus c, okay, that means that I already know the remainder. The remainder is just f of c. F at x equals c, which we just write as f of c. Okay, so the way this works is they're basically saying if you have your polynomial, you divide it by x minus c. What we just learned with synthetic division, I can get this and I can create my synthetic division. And I could do my synthetic division. I could work it all out, I could get answers, and then my very last answer would be the remainder. It turns out that remainder is just the function at c. So that's what this theorem is saying. If you're given this, you can do synthetic division, and your remainder will be f of c. And remember, f of c just means plug c into f. And f of x is the numerator for this problem. So that's the remainder theorem. Anyway, ways we can use this theorem are, well, let's work at these examples. So the way we can do this is I can actually divide these two, and I can find the remainder without using synthetic division. And that's what the remainder theorem has us do. I know that if I did this, C is 1. I already know that if I work this out, I would have, this is the problem that I did earlier. Okay, so from the previous page, I already know my answer is going to be 1. So I know I can do things here, I know I can do things here, but I don't have to. What the remainder theorem says is this number right here is just plug 1 into f of x. And so if I plug 1 into f of x, that's just 2 to the 5th minus 3 to the 4th plus squared plus 1. And that gives me 2 minus 3 plus 1 plus 1. So 2 minus 3 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. And notice that that's what the answer is. So what they're saying is that I can figure out what the remainder is without doing any synthetic division at all. Now on the homework, it's really easy to cheat because you can do synthetic division anyway. But I would recommend that you don't because you want to learn the concept. Anyway, another thing that you can do is I can also use synthetic division to figure out what f of c is. This is a different type of problem. Okay, so it says find f of 2 without plugging in the value. Well, that means that I can just do synthetic division instead. Rather than plugging the 2 in, I can do synthetic division. So this is 1, negative 4, 5, 3. One times 2 is 2. Negative 2, negative 4, 1, 2, 5. So therefore, f of 2 must be 5. Notice that I didn't plug it in. I didn't say 2 cubed minus 4, 2 squared. I instead did synthetic division with it. And my remainder is the same thing as the answer. So these are just some little things you can do to kind of use. On the homework, you see some of these, but there's some applications of the remainder theorem. But the main application, the main reason why we care about the remainder theorem is this guy here, the factor theorem. Okay, so it turns out that the factor theorem, we have a little thing here. It says if f of c equals 0, okay, that means that if I were to divide f of x by x minus c, meaning that I would have c, my coefficients of f, I can't spell right now, coefficients of f, I could do my synthetic division, but I know my answer at the end would be 0, which means that it has a remainder 0. Which means it's a perfect fit. Now the other word for that is it's a factor. So that's the factor theorem. It's saying if you have an x-intercept, and remember that 0, I mean they could be imaginary, but for now let's just say that they're x-intercepts. If you have an x-intercept, that means that when you plug it in, the answer is 0. If the answer is 0, the remainder theorem tells us, well, the remainder is 0. If you divide by x minus c, the remainder is 0. Well, having a 0 remainder means that it's a perfect fit, which thus means it's a factor. Okay? So what the factor theorem tells us is that x-intercepts are equivalent to factors. And this is a really, really, really huge idea. If you know an x-intercept, you know a factor. Okay? So this means that if 2 is an x-intercept, x minus 2 is a factor. If 3 is an x-intercept, x minus 3 is a factor. If 10 is an x-intercept, x minus 10 is a factor. So x-intercepts and factors are the same idea. Okay? So that's why I put here. Finding the zeros of a polynomial is equivalent to factoring the polynomial. So what we mean. Actually, let me go to over here to do another idea for this. So I'm going to do an easy one. Let's say we were dealing with a happy problem. Let's say we had x squared, let's see, minus plus 5, minus 2x minus 35. All right? So what you could do is you get this, you factor it. This is x minus 7, x plus 5. You set it equal to 0. This gives me x minus 7 equals 0. This gives me x plus 5 equals 0. So we have x equals 7, x equals negative 5. When we're doing this problem, we're used to doing it this way, where you start with the expanded form and you end with the x-intercepts. You start with a polynomial and you end with the x-intercepts. Well, what we're saying in this theorem is that I can go backwards. I can completely go backwards. It doesn't matter. So instead, I can start with x equals 7, x equals negative 5, and I can create my polynomial from that. If x equals 7 is an x-intercept, that means that x minus 7 is a factor. If negative 5 is an x-intercept, that means x minus negative 5 or plus 5 is a factor. I can multiply the two together, and that gives me x squared minus 2x minus 35. Okay? So it means that we can go from x-intercept all the way to polynomial. And this was a huge theorem back in the day. People were so used to having the answer, or having a polynomial getting the x-intercepts, but it turns out you can have the x-intercepts and get the polynomial. Anyway, let's go to, not Desmos, so I'll go there in a bit, but let's go back to the problem. Okay. So this first problem says, factor this problem given that 3 is a 0 of f. So whenever they say 3 is a 0 of f, they're telling me that this is an x-intercept. All right? So factor that given that 3 is a 0. So to factor, I know that x minus 3 is a factor. That's what the zero factor theorem says. Or sorry, the factor theorem. If you have an x-intercept, then x minus c is a factor. So 3 is an x-intercept, x minus 3 is a factor. The question is, what's the other factor? So I know that 2x cubed minus 3x squared minus 11x plus 6 is equal to, I know x minus 3 is a factor. The question is, what's the other factor? Well, to figure that out, all I got to do is divide by x minus 3. So that means that my equation is going to be the missing factor. Hello, Gus. Gus is all up in my chair. All right, so let me shrink this so we can fit it. So notice that I just learned how to do this. We can do this with synthetic division. My C is 3. And I can put the coefficients of the numerator up top. I have 2, negative 3, negative 11, and 6. And I can work this out. 2, 6, 3, 9. Negative 11 plus 9 is 2 again. Negative 2, negative 6, 0. Okay, so 3 is a 0, thus it's a factor. So I know that I have to get 0. Why? Because I said so. I told you that it's an x-intercept, so I have to get 0 as my answer. This means that this part right here is my quotient, or the missing factor. So my factored problem is x minus 3, 2x squared plus 3x minus 2. And it turns out that this guy I can use the quadratic formula for. You cannot escape it. Okay, so they want us to factor. Notice that this can still be a factor. All right. Now it's up to you how you want to factor it, but I'm just going to go ahead and use the quadratic formula. Because remember, x-intercepts are equivalent to factoring. Okay, so instead I'm going to do a equals 2, b equals 3, c equals negative 2. And so I have negative b plus or minus the square root of b squared minus 4a times c is negative 4. And then the whole thing divided by 2a. And 2a is just 4. So x equals negative 3 plus or minus square root of 25, which is just 5, over 4. And so I get x is equal to negative 3 plus 5 is 2 over 4, which is 1/2. Negative 3 minus 5 is negative 8 over 4, which is negative 2. So these must be the other two factors. X minus 1/2, x plus 2. So my final answer is going to be combining all my answers together. I already knew x minus 3 was a factor, but now I have the other two because I found the x-intercepts. So my final answer is f of x is equal to x minus 3, x minus a half, x plus 2. Now the only thing we're missing is notice that this guy starts with a 2 up front. And so I'm going to put a 2 up front. We explain that more in the next section, but for now it's just kind of roll with it. So we have the leading coefficient, and then x minus x-intercept, x minus x-intercept, x minus x-intercept, where all of these guys here are x-intercepts. And that's how we factor polynomials. It always works. If you find the x-intercepts to a polynomial, you know how to factor it all the time. Okay, so let's do this next one. Only got 2 more left. This section is very theory heavy, meaning that the math we're doing, it seems kind of all over the place unless you understand why you're doing it. So please email me if you have any questions. Usually, if I'm in a face-to-face, I have more interaction and I can talk to you a little better. So please email me if you're confused with this. So let's do this next one. Factor this problem given the graph. This is exactly the same as the one we just did, except that now I give you a picture instead. And so here, notice that I gave you an x-intercept. So automatically I know that that's -1. So that x plus 1, let me write it like this. X minus -1 is a factor, which turns into x plus 1. So I know that x plus 1 is a factor. Okay. For the same logic, I can divide it to figure out what the other factor is. So I can do, so we have 15x cubed plus 14x squared minus 3x minus 2. And I found out that that's equal to x plus 1 because I gave you the graph and showed you the x-intercept. But then there's the other factor. So the other factor, we just divide my x plus 1 to the other side. So that's where we get my synthetic division. So with this, I can do synthetic division. I know c equals -1. So I can do -1, 15, 14, -3, -2, and we work it out. Now I know I have to get 0 at the end because it's an x-intercept. It has to work out. If not, it means that either you messed up or I lied to you. That actually happened once where I had a typo in my problem, and I had many confused students. So 15 times that is -15, -1, +1, -2, +2, and notice that everything checks out. So this is the other factor. Yeah. So remember, this is 15x squared minus x minus 2. That's the other factor, but I'm just going to go ahead and just go straight to doing the quadratic formula. So looking at this, I already know that a is 15, b is -1, c is -2. So I have x is equal to -b plus or minus the square root of b squared minus 4a times c. Then the whole thing divided by 2a. 2 times a is 30. So 1 plus or minus. This is square root of 121, which we know is 11. So that's going to be equal to 12 over 30, which is 2/5, or negative 10 over 30, which is negative 1/3. Again, each of these corresponds to a factor. This means that x minus 2/5 is a factor. This means that x plus 1/3 is a factor. Combining all my factors together, I know that my equation is going to be, it started with a 15, so that's my leading coefficient. But then I know it's going to be x plus 1, x minus 2/5, x plus 1/3. Because remember, I knew the first factor, and I did synthetic division with it to figure out what was left. What was left was a quadratic, so I just went ahead and did the quadratic formula. Now, when you do the quadratic formula in this section, it's always going to end up being nice, happy answers. So you shouldn't get like 3 plus or minus square root of 7 over 8. That's going to be kind of nasty. You'll get nice, fun answers, and those are going to be the factors that you use to create your polynomial. Each x-intercept is a factor. X-intercept factor. 3 x-intercepts, 3 factors. And then the coefficient goes up front. All right. So, got 2 more problems to do, and then we're done. These are all just different problems you're going to see on the homework. So every one of these you're going to see on the homework. Find a polynomial of degree 3 with zeros of -3, 2, and 5 going through the following point. All right. So here, notice that they gave us 3 x-intercepts. I'll just put x-intercept. So that means automatically I know my 3 factors. If -3 is an x-intercept, x plus 3 is a factor. If 2 is an x-intercept, x minus 2 is a factor. 5 is an x-intercept, x minus 5 is a factor. Okay. Now, from the last 2 examples, the only thing we're missing is this number up front, which we're going to call a. The question is, what is the leading coefficient? I'm going to put y equals in front of it. If not, you'd be done. There's some problems on the homework where actually that's all they want you to do. They say find a polynomial with these x-intercepts and a leading coefficient of 1. If you know what the leading coefficient is, you're done. And that's pretty much the happiest problem ever. Now, the reason why we can't just stop there, let me erase all this. So I have x minus 3, x plus 2, x plus 5. Right? Let me put it back over here. Plus 3 minus 2 minus 5. Plus 3 minus 2 minus 5. Sorry. So if I hit A as a slider, and I make it just go between -2 and 2, and I'm going to change the y-axis. Let's make the y-axis pretty big. Let's go from -50 to 50. Okay, I'm going to hit play. So 3, 0. Sorry. -3, 0. 2, 0. And 5, 0. All of these are x-intercepts, just like I said they would be. Right? But I'm going to hit play. Notice that there's an infinite number of polynomials that have those three x-intercepts. Every different value of a is a different polynomial. And so we're looking for the one polynomial such that it goes through the point. So they need to give you more information. They say that it has to go through the point 1, negative 32. So I'm going to type in 1, comma, negative 32. And let's see if we can find that polynomial. So it's not these. It turns out it's going to be, boop. So it should be a equals negative 2. Because notice that that goes right through the given point. So here, we don't just write negative 2 because I was cheating with Desmos. We're going to figure this out. Notice that this point says that x equals 1, y equals negative 32. Well, we're just going to get that, and I'm going to plug it in. That's it. That is all you got to do. So if I plug it in, I get negative 32 equals a. I still don't know what a is. And then here, I know this is plus 3, minus 2, minus 5. This is going to be 1, 1, 1. So x is 1. There's 3 of them. Y is negative 32. And I can work it out, and now I can solve for a. 1 plus 3 is 4. Negative 1. Negative 4. Negative 32 equals double negative is 4 times 4 is 16. And notice that when I do that, I can solve for it, and I get exactly what Desmos was telling me. So my final answer is negative 2 times x plus 3 times x minus 2 times x minus 5. Now that's what I want. I am perfectly happy with this answer. However, if you're doing it online, sometimes they might want you to expand it. And to me, that's just a bunch of busy work. That's just a bunch of, it doesn't really have to do with what we're doing. So I'm okay. If you can know how to get the answer that I just got, you can go to, let's say, Mathway or something. Is that the one you all use? And you can go ahead and type it in. Negative 2x minus 3, x plus 2, x plus 5. And you just say simplify, and it gives you the answer. So negative 2x cubed So again, I'm not saying that you use Mathway to do it. It's just that foiling it all out, expanding is busy work. It takes forever. And why do I always type it in wrong? Hold on. Or which one is which? Which one's the wrong one? Hold on. Ugh. Why is this not working? Plus 3, minus 2, minus 5. Okay. Sorry. Okay, plus 3, sponsored video, minus 2, minus 5. All right, and so when you work it out, or if you FOIL it, you get negative 2x cubed plus 8x squared plus 22x minus 60. Again, this one, the homework might make you do this. If it does, I am perfectly fine with you just using Mathway to go ahead and expand it. My main focus is that you know how to get the factored form. All right, so let's do this last one and then we're done. Woo. Okay, so looking at this problem, we can see that I have x-intercepts. I know it's a little blurry. So here there's an x-intercept, but you have to notice what it does. Notice that this touches the graph. Notice that this one here, it crosses, but as a straight line. Whereas here, it crosses, but notice that it looks like a cubic as it does it. So there's 3 different ways it crosses, and each one is a different multiplicity. If it looks like x cubed, remember that the multiplicity is 3. It crosses a straight line. That means the multiplicity is, so hard to write that word, is 1. Here, the multiplicity is 2. Okay? This means that when I'm writing my equation, first, I don't know what a is. I need to figure that out. But I know that x plus 5 is a factor. X minus negative 5. But not only that, it occurs 3 times because of that curvy shape. So I know that this has to be x plus 5 cubed. Here, the second one crosses straight through. So there has to be x plus 5 to the 1. This one touches. It does a little bounce thing. So that's x minus 2, but that has to be squared. So the multiplicities tell you what the exponent for each factors are. Now I can go ahead and I can plug in the point. This point is telling me that if x equals 0, y equals negative 125. So I'm going to get that and I'm going to plug it in here. Okay, so we work it out. Negative 125 is equal to 5 cubed. 5 times 5 times 5 is 125 times 1 times negative 2 squared is 4. Okay, so negative 125 is equal to, and we can multiply that through, but notice that I'm just going to keep it as 4 times 125a, because when I divide it over, notice the 125's cancel. And so I get negative 1/4 is equal to a. So your final answer is f of x is equal to negative 1/4 x plus 5 cubed, x plus 1, x minus 2 squared. There is no way that I'm going to expand that by hand because that is going to take forever. So I go to Mathway and I type it in. And again, it's not that I'm cheating, it's just that expanding a polynomial like this is a remedial topic, and we don't have time to recover a remedial topic like this. Also, it's extremely time consuming. And so I'm going to simplify that. Unable to solve it. Let's try it one more time. That's kind of funny. Why would Mathway not know how to? Maybe I picked the wrong option. All right, so Mathway kind of stinks here. So there's another website that I like to use called Wolfram Alpha. And it's kind of the same idea. So I'm doing the same thing. I'm typing in the number here. Notice I'm putting carets for the exponents. So input, make sure you typed in the right thing. There's the graph. And there's all the different ways you can write it. For some reason, if you wanted to write it like that, you could. But if you go through, you should see the expanded form. And notice that that is nasty. So, oh. So negative 1/4 x to the 6 minus 3x to the 5th minus 15/2 x to the 4th plus 24 x cubed plus 315 over 4x squared minus 75x minus 125. Yeah, there's no way I would make you do that. Gilbert is content with that being your final answer. But if the homework made you, then go ahead and use the internet. And if the homework makes you, do that. Anyway, let me know if you have any questions with the homework. This section is very theory-based. So everything I'm doing seems like complete nonsense unless you understand the logic behind each step. Like, why am I churning? Like from the last section, why am I making it cubed? I'm making it cubed because it does the little curvy thing as it crosses. Why am I making it squared? I'm making it squared because it bounces. Anyway, let me know if you have any questions, and have a good night. I need to go to sleep.